In this video, we're going to demonstrate how the DeepView Vision Starter Kit Micro was used to build a real-world remote vehicle detection system for a parking use case. The micro vision sensor is ideal for remote site monitoring with limited connectivity, as all the image processing and machine learning is performed at the edge in the sensor, with only low bandwidth location data being reported up to the cloud dashboard. The first step in building this system was implementing the training workflow. Here the microsensors were configured to capture images and upload them to the cloud server. The captured images are then manually annotated with the ground truth bounding boxes, or in this case, we used a larger cloud model to automate this process. This dataset automation will be detailed in a future video. Next, the NXP EIQ portal tools were used to train an optimized DeepView RT Edge model for deployment to the vision sensor. Once the model is downloaded to the micro vision sensor, it can perform vehicle detection in real time and report the metadata to the cloud, indicating the number of vehicles detected and their location. In this example, reference images were also sent to the cloud periodically just to validate and visualize the edge detections. This would not normally be required on a production system. Here is our setup of the example parking lot with the DeepView micro sensor. In this case, power and wired Ethernet were used to connect the sensor to the cloud, but this could also be implemented using Wi-Fi or the integrated LTE modem as well. For this use case, we are monitoring an unstructured gravel parking lot without specific spots or markings. Multiple sensors could be used for coverage depending on the application. Here we used two sensors configured for reporting. We used the NXP EIQ portal GUI-based tool to manage the dataset, train the detection model, and optimize it for the vision sensor. The Dataset Curator workspace is used to browse the image dataset and define the vehicle ground truth bounding boxes for training. Here you can see the regional-specific labels which were generated. It's important to capture a diversity of images under different lighting and weather conditions to achieve a robust, accurate model. Once the dataset is complete, we can select and train a detection model. The training step has been skipped over here for brevity. The results are shown here with good results achieved after about 5 epochs of training. Here you can see the loss function, which gives a good indication of when training is complete. After training, it's important to validate the model with captured images which were not used in the training process. We display these results on a confusion matrix, and then we can select various test images which confirm that the detection bounding boxes in green match the ground truth boxes shown in blue. As you can see here, the machine learning implementation is robust, providing accurate results for very different environmental conditions and vehicle types. This is one of the key advantages over a system implemented with traditional image processing algorithms. The DeepView Vision Sensor Micro also uses a high dynamic range image sensor with an optimized image processing pipeline. This is required to deliver very good results over a wide range of challenging lighting. The micro vision sensor has an integrated DeepView Middeware stack for cloud reporting. The first overview page of the example cloud application dashboard shows a heat map of the parking lot with the colors representing the frequency of vehicles parked in a given area. We can also click on the sensor to see the last reference image captured by the sensors. For a production system, we would just send the low bandwidth metadata indicating the time and position of the vehicle's detection. We have for this system figured it to also send the reference image, which is used for detection. This allows us to visualize and demonstrate the accuracy of the edge detection, which is displayed with the yellow bounding boxes. The green validation bounding boxes are generated with a larger, higher performance detection model running on a server. You can see the high degree of correlation between the yellow and green detection boxes, confirming the accuracy of the detections performed by the micro vision sensor. This application demonstrated a parking lot monitoring system, but the building blocks used here could be used for other applications such as asset monitoring of remote sites, material tracking for construction, or the intelligent control of overhead doors. The DeepView Vision Pack, Model Pack, and Application Packs provide you with the IP, services, and support you need to get to market faster with lower risk for your custom sensor solution. Please contact Ozone for additional information.